In this video, we want to look at how small adaptations to our base parabola or simplest parabola of y equals x squared can yield predictable results. So we're going to look at three key ways in which we can change that very simple parabola and show how its resulting parabola not only can be predicted, but how we can know what it's going to look like even before we draw it. But we're going to do that in reverse. Let's draw first, then we can learn about the predictions. So I'm going to help you with this investigation by doing some of the examples for you, and then you'll be able to fill in the rest. We're going to begin by creating our own table of values. So I have chosen x values, a couple of them in the negative region. I've included 0 and then a few values in the positive region as well. And you notice that I've chosen to go up by regular increments as well, just to make it a little bit easier. So when we look at what would y be equal to if it's equal to x squared? Well, x, if it has a value of -3, would be -3 times -3. Now be careful. You have to multiply the signs together, negative times negative, and the values 3 times 3 together. So the outcome would be 9. What happens if you square -2? Well, -2 times itself is positive 4. -1 times -1 gives 1, and 0 squared gives 0. On the positive end of things, you'll notice a really interesting pattern develops. 1 squared is 1, 2 squared is 4, and 3 squared is 9. Look at how it kind of decreases down to 0 and goes back up again. So let's begin by graphing that simple parabola. And I'm actually going to begin with 0, 0 first, because that's the easiest one to point. And then I'm actually going to do these positive region first. So I'm going to go over 1, up 1, over 1, up 1. And notice that I've chosen axes that are not going up by exactly the same increments, and that's totally okay. I'm going to do some estimating, but on your worksheet, you've got some graph paper that is to scale. So I'm going to estimate 1, 1, over 2, up 4. Over 2, up 4 might look something like this. Over 3, up 9 might look something like this. And I'm going to do the same thing in this negative region as well. Okay, so over 1 to the left and up 1, over 2, up 4, over 3 to the left, up 9. I'm just going to drop that one down a little bit. There we go. And 3, 9 might be something like this. And then we're going to smooth curve these points together because they are not a straight line. So I'm going to imagine a little bit dive bombing, like a jet starting up here. Connect. I want it to be smooth around the bottom. And most importantly, I want to include arrows at both ends because this parabola could keep going in both directions. I'm just showing a small section of it. So now I want to know what happens if, instead of having a value of 1 in front of x squared, what if I have a value of 2 instead? Well, in essence, all I'm doing is I'm going to double the values I had before for the x squared parabola. So doubling 9 means y would become 18. Doubling 4 means y would become 8. Doubling 2, doubling 0, and you'll see a similar pattern evolve down here. So let's graph this one with our base parabola to be able to compare and contrast them. Again, I'm going to start at 0, 0 because that's an easy one. And I'm going to go over 1 because that's my x value, and up 2 this time. So it's going to be a little bit higher in both sides, right, than it was for the pink parabola. Then I'm going to go over 2 and up 8. So again, it's going to dip quite a bit higher than the pink one. And then over 3 and up 18. And if I connect these with a very smooth curve, arrows on the sides, there's my graph for y equals 2x squared. I know it's not perfect, but you can appreciate that it would be perfectly symmetrical. It actually has almost like a fold or a line down the center. We call this the axis of symmetry, that if I were to take the right side of the page and fold it over top of the left, along that axis of symmetry, these curves would line up perfectly on top of each other. So let's explore what would happen if, instead of doubling our base parabola, what if we triple it? So 3 times our pink one. So 3 times 9 would be 27. 3 times 4 would be 12. 3 times 1 would be 3. And we have a similar pattern going down here as well. I mean, conversely, you can just take this x value, sub it in, recognize that exponents get done before multiplication according to BEDMAS. So negative 3 squared would be 9, times 3 would be 27. And you could do that by subbing in each of these x values into this equation. You would get the same result. So what happens when I graph this one? Well, again, I'm going to start at 0, 0, because that one's easy. And this time, if I go to the right or to the left over 1, I'm going to have to go up 3. And if I go over 2, either to the left or the right, I'm going to have to go up 12. And if I go over 3, both directions from 0 to either plus 3 or minus 3, I'm going to have to go up to a y value of 27. Which is going to be up here somewhere, approximately. So, let's try that again. There you go. So it would appear that if we put a value in front of this x squared term that is bigger than 1, the bigger it gets, going from 1 to 2 to 3, the steeper or the more stretched this parabola becomes. So when a is bigger than 1, our parabola seems to stretch out. In your investigation, you're going to explore what also happens. What if a is less than 1? What if it's a fraction or a decimal less than a value of 1? What will happen to the parabola? And you can imagine we'll probably do the opposite. It will go wider or become more compressed. I'm going to jump down to the bottom of your investigation. I'm also going to explore y equals negative x squared. So in this one, what would happen? Well, I've already done all the x squared values, right? And I'm just going to take the negative of them. So I would have negative 9, negative 4 for y, negative 1, 0, and negative 1, negative 4, negative 9 all the way down. So when I plot those, what would they look like? Well, I'm going to have to get into the negative region of the y-axis, and I'll sketch this for you. I would have 0, 0. I could go over 1 in both directions to positive 1 and negative 1, and I would have to go down 1. And then I could go over 2 in both directions, but I would have to go down 4. And I could go over to positive 3 and negative 3, and they'll both have a value of negative 9. So I can sketch the curve to look like this. And what's really neat about it is that it would seem then that if the value of a here is a negative number, what that's going to do is it's going to generate a parabola that faces downward as opposed to one that faces upward. Okay, and that's how we could easily change that parabola. This starts to get into all kinds of real-life applications. Anything that is thrown, any projectile motion, all follows negative parabola patterns on Earth. What also is cool is that if you examine the pink one and the blue one, they have a line of symmetry about the x-axis. You could fold it this way, and your sad face would superimpose perfectly on top of your happy face, because this one has an a value of positive 1, and this one has an a value of negative 1. Okay, let's explore some other ways that we can manipulate this y equals x squared, our base parabola. And unfortunately, I'm going to have to erase this one just to continue, but that's okay. All right, so this time, let's draw in a new y-axis, and let's explore changing it in a way that results in a different predictable pattern. It would appear then that A is responsible for upward and downward, depending if it's positive or negative, and also how stretched or compressed it is depending on the value of A. What happens if we do something to x before we square it? So what we're going to do is we're going to begin with our y equals x squared friend, and you're going to get really used to drawing this one because you'll see that it has a very predictable pattern. Similarly, if I do 4 squared or I do negative 4 squared, what do I get? I get 16 in both cases. And 5 squared, whether it's negative or positive, also results in a value that is identical to each other, a value of 25. Now, I'm not going to plot all of those, but there is a reason why I have that full range there. So let's do a little sketch. This time, let's change the x-axis a little bit. You have varying ones in your investigation. I'm going to just do this for demonstration purposes so that it covers all the bases I want to cover in this lesson. And here I'm going to go up by, let's do some other thing. Let's do 5, 10, 15, and 20. Okay? So let's quick plot the base one, the pink one that we like to compare to. So we have 1, 1 in both directions, 0, 0, over 2 up 4, over 2 up 4, over 3 up 9. Like I said, you'll start to get really good at this one through practice. Even for now, I could do up 4 to 16 and up 5 to 25. I'll leave the 25 because it'll be way up here. You get the idea. There you go. There's our base parabola. All right, what happens if we take away a value of 1 before we square it? So let's start at 0, 0, because that's the easiest place to start. If I have 0 minus 1, that will give me a value of negative 1. Negative 1 squared is positive 1. Okay? Let's finish off these values, and then we'll come back up to these ones. So if I put in 1 for x, 1 minus 1 would be 0. 0 squared gives me a y value then of 0. Let's put in 2 for x. 2 minus 1 is 1. 1 squared is 1. Let's put in 3 for x. 3 minus 1 is 2. 2 squared is 4. Putting in 4 for x. 4 minus 1 is 3. 3 squared is 9. See a pattern evolving? Can you predict this next number before we even put it in? Well, let's put it in, check. 5 minus 1 would be 4. 4 squared would be 16. Can you predict what these values might be even before we sub them in? Well, let's sub them in and check. Let's put negative 1 into x. Negative 1 minus 1 would be negative 2. Quantity squared would be a value of 4. Negative 2 minus 1 would be negative 3. Negative 3 squared would be 9. And we start to see a pattern evolve, okay? Now, some of these squares in your investigation are grayed out. You don't actually need to calculate them, and the reason for that is that when you go to graph them, they'll be off the page, okay? So this is kind of a hybrid of key points I want to show you leading into your investigation. So let's plot this. Now, I notice that at 0, my y value is 1. Okay, so it's going to be right there. So I've done that one. I'm going to work my way down to these guys. So if I go over 1, I'm going up none. And then I'm going to go over 2, up 1. Over 3, up 4. Over 4, up 9. Over 5, up 16. So far, what do you notice has happened to this parabola? It would appear that maybe it's been shifted to the right. Let's confirm by adding in these points too. Let's go over to negative 1 and up 4. And then we'll go over to negative 2 and go up 9. and then go over to negative 3 and up 16. We could even include negative, well, we can't do negative 425, sorry, because my graph doesn't go up that high. Take a look at this. Let's sketch it in. So it would appear that if we take away something from x, we end up shifting to the right. Now that seems really counterintuitive. We'll talk about that after I do this next example. All right, let's see what happens if we add 2 to x before we square it. And yes, that is a square. I'm going to begin at 0, 0 again because that's the easiest one to plug in. 0 plus 2 would be 2 squared, means my y value would be 4 when x is 0. I'm going to do this section next. 1 plus 2 is 3. 3 squared is 9. 2 plus 2 is 4. That would be, give me 16 when it's squared. 3 plus 2 is 5. Squared would be 25. And you already know that, again, it's going to run off this graph. No problem. Let's go back and do these ones. Negative 1 plus 2 would mean give me a value of positive 1 squared. Gives me a 1. Negative 2 in here, plus 2 is 0 squared, which would be 0. See a pattern? So let's graph this and see what happens. Okay, I'm going to start at 0, just because it's just a habit that I like to do. So I'm going to go to 0, 4. That's right there. And then I'll do these guys. I'm going to go over 1 up to 9, over 2 up to 16, and I can't do over 325, and that's fine. Let's go back and do these ones now. I'm going to go over negative 1 up 1. That'll put me there. And then over 2 up none, right on the x-axis. To the left 3 up 1. To the left 4 and up 4. So here it is. And can you predict where the next one would be? If I did negative 5, negative 5 plus 2 gives me negative 3 squared would be 9. Okay. Don't know why that happened, but we're good. There. And you can see that this parabola has been shifted to the left compared to the pink one, even though it says plus 2. So we'll come back and consolidate that a little bit later. Right now I just want you to see what happens. It appears that what you see is the opposite to what you get. Okay. Last piece in the investigation, I want us to see what happens if we have our y equals x squared friend, but then we add or subtract something to it after the squaring as opposed to before the squaring. So I'm just going to take a moment to take this one off. Actually, we'll start from scratch. And you can begin, this is on page 3 of your investigation, by putting in your values for here, because I'm hoping by now you see the pattern. Over 1 up 1, over 2 up 4, over 3 up 9. Okay, I'll put in an axis here. I'm going to go by 3s this time. And I think I'll go up by 10 again. Let's try that. All right, so 1, 1, 0, 0. Over 2 up 4, over 2 up 4, over 3 up 9, over 3 from the center here, up 9. Bam. There you go. All right, so now what we're going to do is we're going to take this value and we're going to add 2 to it because we've already done the math here. So 9 plus 2 is 11, 4 plus 2 is 6, 1 plus 2 is 3, 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, and 11. And let's plot this. I'm going to start here because I like starting sort of in the center and then going right and going left. Again, that's just my preference. So 0, 2 would be about here. And then over 1 up 3, over 2 up 6, over 1 up 3, over 2 up 6, over 3 up 11. And there'll be a similar pattern here, here, and here as well. And we can draw it in. So what do you notice about this parabola? And again, mine isn't to scale. Yours will be much better because you've got grid paper on your investigation. But it would appear that if we add 2 after we've done the squaring, what it's successfully done is taken the pink one and shifted it upward along that axis of symmetry, which happens to be the y-axis for now, moved it up 2, taken everything and moved it on up. So what do you suppose happens if we take away 1 instead? Well, let's go back to this value, which is the value for y equals x squared. So that'll take care of this part, and then subtract 1. So we have 8, 3, 0, negative 1, 0, 3, and 8. Let's plot this. So I've got 0, negative 1 right here. And then I can go over 1 in both directions from here, and I'm going to go up to 0. It's going to hit the x. Whoops, let's do it there, sorry. Over 2, up 3. And then over 3 in both directions and up to 8. Okay, so again, it would appear that if we do something to our base parabola after the squaring, that we get that exact result that we see. So adding 2 shifts the parabola up 2, taking away 1 shifts the entire parabola down 1. There's a lot of cool patterns involved in here, and through this investigation, my hope is that you will see the role of A in terms of predicting upward and downward and also stretch and compression. That H has the ability to shimmy left and shimmy right, but kind of opposite to what you see. We'll talk about that in the next video. And then finally, that we can do something after the squaring, and that'll shift the parabola up or shift the parabola down. Those are so important to know. Take the time to do the investigation and to fill in the summaries at the bottom of each page so you see the big ideas.